Hey everyone, it's Japoo, and today we're going to talk about increasing and decreasing functions. So just a reminder before we get started, the worksheet that I'm about to do and its answer key are linked in the description below, so feel free to check that out if you would like to follow along. Now let's talk about how to find when a function is increasing or decreasing. So to find whether the function is increasing or decreasing, your first instinct may be, oh, we should draw the function itself and then find out via that graph where the function is increasing and decreasing. However, drawing the graph of the function is usually pretty difficult. So we actually want to draw a different graph where we can look at values and kind of interpret whether the original function is increasing or decreasing. Today we're going to draw the graph of f prime, or the slope of f, and then we're going to figure out where the f prime graph is positive and where the f prime graph is negative, and then determine whether the function is increasing or decreasing based on that. When f prime, or the slope, is positive, the original function f is going to be increasing. When the slope, or f prime, is negative, the original function, or f, will be decreasing. So that's how we can find out whether the function f is increasing or decreasing without having to draw the graph of f. The other thing we're going to actually talk about today is also how to find where a critical point of f is. So again, we're not really going to draw the function itself. We're going to draw the derivative of the function, f prime, or the slope of the function. And a critical point or number is where f prime of x equals 0 or does not exist. So whenever we have a problem that asks us to find whether a function is increasing or decreasing, or to find a critical point of a function, we're going to follow these steps. We're first going to take the derivative of the original function to give us an f prime graph. Then we're going to factor the derivative as much as possible. Then, based on our factored equation, we're going to draw a sign chart. We do have a video on how to draw sign charts, so if you're unfamiliar with sign charts or want a little more practice, feel free to check that out. After we draw our sign chart, we can then determine where f prime is positive, negative, or equals 0 or does not exist, and then we have our answer. For these answers, what you want to do is write a full sentence. You want to include the question, so you want to say like f is increasing or decreasing at the answer or on the answer, because it's going to be an interval, and then you're going to write the rule as well, because f prime is positive or negative or equals 0 there. It's really important to have all of these components in your answer, because especially on the AP exam, they are looking for like those components to give you points. So make sure that you have the full answer, because it's really easy to go through all of these steps and then just mess up the answer a little bit. But once you get a hang of it, it's going to just kind of be the same thing over and over again, so it's pretty easy. Let's go ahead and practice. So our first actual problem is going to be about finding where f is increasing. So we're actually given f prime, we're given the derivative already, so we can skip step 1. And it is already factored as much as possible for us. So that's pretty nice. All we really have to do in this case is draw the sign chart. So the sign chart for this function is going to be odd positive, because if you kind of add up the exponents, you're going to get an odd number, and it's a positive function, there's no negative sign in it. And we're just going to go ahead and draw our sign charts. So we know that in our sign chart, the line is going, or the curve is going to hit the axis at -1, 3, and 6. So we start negative. We start at the bottom. And then since x plus 1 is squared, we know that it's going to bounce at -1, like this. It's going to bounce at -1. And then it's going to cross through it's going to cross through 3, because x minus 3 is to the 5th power. And it's going to bounce at 6, since x minus 6 is to the 4th. So our final answer is going to be written as f increasing, so that's the question, on, in parentheses, 3, 6, and 6, infinity. That's our answer, because f prime is greater than 0, or positive there. And that's our rule. So as you can see, we have all 3 components in our answer. We have the question, f increasing, the actual answer that we found from the sign chart on the interval 3 to 6 and 6 to infinity, and then the rule, because f prime was greater than 0 there. Make sure that when you're writing the intervals, you separate the intervals based on where they touch the axis. So as you can see here, I split up 3 to 6 and 6 to infinity because it hits the axis right here. So I can't say 3 to infinity. I have to say 3 to 6 and then 6 to infinity. Okay, let's move on. So for, I think, the rest of these problems, yes, we're going to just be finding the critical points and where the function is so the critical points of the function and where the function is increasing or decreasing. So the first step for number 4 is obviously to take the derivative of the function, and we have that here. It's 10x plus 6. And we can factor that a little bit to get 2, and then in parentheses 5x plus 3. Or I guess that's not factoring, that's just taking out a number. Yeah, it's 2 times 5x plus 3. So we're going to mark -3/5 on our sign chart. This sign chart is going to be odd positive. It's basically just going to be a line going from negative to positive. So the critical point in this case is x equals -3/5. And you should write this, I forgot to write this in this problem, but you should write because f prime is equal to 0. So I have critical point, which is the question, x equals -3/5, which is the answer, and I should have because f prime equals 0, because that's the rule. And we know f is increasing on the interval -3/5 to infinity, that's this portion right here, because f prime is positive there, as we can see on our sign chart. And then we know that f is decreasing on -infinity to -3/5 because f prime is negative over there. So again, make sure you have all 3 components for your answer. So moving on to the next one, we're going to take the derivative of the y equation, and that's going to give us f prime equals -6x squared plus 6x plus 36. And then we can actually factor that a little bit. First, we're going to take out a -6, and that'll give us x squared in parentheses minus x minus 6. And we can factor that little expression inside the parentheses to give us -6 times x minus 3 times x plus 2. So like that. So that means that on our sign chart, we're going to have the curve or the line touching the axis at -2 and 3. So this sign chart is going to be even negative. So it's kind of going to be an upside down parabola. And it's going to look something like this. So we know our critical points are going to be at x equals -2 and x equals 3, because f prime of 0 is, or f prime of is, because f prime is 0 there. And we can see that f prime is negative from infinity to -2 over here, and 3 to infinity over here. So we can say, and then we see that it's positive from -2 to 3 at the top right here. So we're going to say that f is increasing on -2 to 3 because f prime is greater than 0 there. Be careful with your f's and f primes. It does get a little confusing because they're very similar, but that's probably the most important thing that you have to remember, distinguishing f and f prime. F is what you're looking for, f prime is how you get there, if that helps a little bit. And then we have f is decreasing on -infinity to -2 and 3 to infinity, because that's where f prime is less than 0 or negative. And so I prefer writing it in this order. Technically, you can write it in whatever order you want. I just like doing the same thing every single time. You could say, since f prime is negative at or on -infinity to -2 and 3 to infinity, f is decreasing there. You can write something like that. You just have to make sure that you have all 3 components. Okay, so for this next one, we're again going to take the derivative of y. Make sure you always take the derivative. I know sometimes when the problems get a little more complex, you might just want to go ahead and try and factor the equation or something, but make sure that you first take the derivative so we're working with the f prime equation. So the derivative for number 6 is 12x cubed plus 24x squared minus 12x minus 24. I'm going to go ahead and factor by grouping here. So I'm going to have 12x squared in parentheses x plus 2 minus 12 times x plus 2. And then I'm going to factor by grouping. So finish that step. I'm going to get 12 times x squared minus 1 times x plus 2. And I can actually factor x squared minus 1 more to get a final completely factored answer of 12 times x plus 1 times x minus 1 times x plus 2. So we know that we're going to have points on the graph at -2, -1, and 1. On our sign chart, sorry, at -2, -1, and 1. So that's going to be odd positive. And so we're going to start at the bottom. We're going to start in the negative. And we're just going to go up through -2, down through -1, and back up through +1. So it's going to look something like this. We see that we have critical points at -2, -1, and 1, since that's where f prime is equal to 0. And we see that f prime is positive from -2 to -1 right here, and then from 1 to infinity. So we're going to write f increasing on -2, -1. And 1, infinity, because f prime is greater than 0 there, or it's positive there. we see that the sign chart is negative right here and right here. So f is decreasing on negative infinity to negative 2, and then negative 1 to 1. Because f prime is less than 0 there. All right, let's move on to the next page. It's just going to be more of the same. We're finding the critical point of the function and where the function is increasing and decreasing. So for number 7, again, we're going to first take the derivative of the function. In this case, we're going to get 5x to the 4 minus 3x squared. We can factor that equation to give us x squared times 5x squared minus 3. And we could factor 5x squared minus 3 to give us x minus square root 3 over 5 and x plus square root 3 over 5. So that's going to be our fully factored form. We're then going to go ahead and make a sign chart for this f prime function. It's going to look something like a parabola since it is an even positive graph, except there's going to be kind of like an indent in the middle where the sign chart bounces at 0, since we have x squared. So this is what our sign chart is going to look like. And we'll go ahead and find the critical points. So we know that the critical points are where x equals negative square root 3 over 5, positive square root 3 over 5, and 0, because that's where f prime equals 0. We know that f is increasing over here where f prime is positive. So we're going to have f increasing from negative infinity to negative square root 3 over 5, and then from square root 3 over 5 to positive infinity, because that's where f prime is greater than 0. F is going to be decreasing from negative square root 3 over 5 to 0, and 0 to square root 3 over 5, because that's where f prime is negative. Again, we do have to split up the interval at 0 because technically f prime is neither increasing or decreasing at 0 f is neither increasing or decreasing at 0 since f prime is equal to 0 at 0. It's a lot of zeros. But that's going to be our final answer for number 7. Then we'll move on to number 8. Number 8 is not a product rule. We don't, not a quotient rule. We don't factor by doing the quotient rule since we don't have an x in the numerator. We can kind of rewrite the y equation as y equals 2 times, and then in parentheses, x squared plus 7 to the negative 1 power, bringing everything from the denominator up by putting it to the negative 1 power. And then we'll get, when we take the derivative of that, we will get negative 2 times 2x over x squared plus 7, and all of that is squared at the bottom. We can simplify the numerator of this fraction by multiplying negative 2 and 2 to get negative 4x at the top. And we're actually not going to consider the denominator in this case in our sign chart, since x squared plus 7, all in parentheses squared, is always positive. It's always going to be above the x-axis, and therefore we don't consider it in our sign chart because the sign isn't going to change in that interval or whatever. So we're only going to have 0 in our sign chart. This is an odd negative graph. It's basically a line going from positive to negative. So the only critical point we're going to have in this case is x equals 0, because that's where f prime equals 0. F will be increasing from negative infinity to 0, because that's where f will be increasing from negative infinity to 0, because that's where f prime is positive. And f will be decreasing from 0 to infinity because that's where f is less than 0, where it's negative. Number 9, we're going to be using the product rule. So we're going to get x minus 2 to the power of 3. I did kind of write my 3 a little lower than it should be. It is x minus 2 to the power of 3, not x minus 2 times 3. Be careful of that. Plus 3x times x minus 2 squared in parentheses. We can take out an x minus 2 to give us x minus 2 in parentheses, and then in another set of parentheses, x plus 3x minus 2. We can further factor x plus 3x minus 2, which will give us a fully factored form of 2 times x minus 2 squared in parentheses times 2x minus 1. Sorry, I don't know why my handwriting was like slanting up, but this will be our final answer, and we're going to go ahead and draw our sign chart. We're going to have an even positive sign chart with points on the axis at 1/2 and 2. So our sign chart's going to look something like this. Our critical points will be at x equals 1/2 and x equals 2, since that's where f prime equals 0. F is increasing where f prime is positive, or in this case from 1/2 to 2, and 2 to positive infinity. F will be decreasing from negative infinity to 1/2, because that's where f prime is negative, based on our sign chart. I wanted to remind you guys again, when you're doing these problems, to factor as much as possible. Like in this problem, we did have to factor a couple of times. We did have a couple of steps to take until we got to our fully factored form. Make sure you're taking all of those steps so that you can properly draw your side chart. Super important. Anyway, this is going to be our final answer for number 9. And we'll move on to number 10. In number 10, we will actually be using the quotient rule to find our derivative, since we do have x's in both the numerator and the denominator. So what we're going to have is, in parentheses, x squared plus 1 minus 2x squared over x squared plus 1 all squared. Remember, when we're taking the derivative via the quotient rule, we kind of follow that pattern, low d high minus high d low over low low. We can simplify this to give us negative x squared plus 1 over x squared plus 1 all squared at the bottom. We can factor the top of this equation to get negative x minus 1 times x plus 1 over x squared plus 1 squared. Since x squared plus 1 squared is always positive, we're actually not going to consider that when we are drawing our sign chart, and we're just going to consider x minus 1 and x plus 1 in the negative sign. So in this case, our sign chart is going to be even negative. It's basically going to be an upside down parabola, and it's going to cross the axis at -1 and 1. That means that in this case, our critical points are at x equals -1 and x equals +1, because that's where f prime is equal to 0. F is increasing where f prime is positive or greater than 0, so between -1 and 1. That's where it's above the x-axis. And it's going to be decreasing at -infinity to -1 and 1 to +infinity, because that's where f prime is negative, as you can see. All right. Now we're moving on to number 11. Number 11 is going to use the chain rule, so be on the lookout for that. And our derivative will be 2x plus 3 over, and then I went ahead and factored what's going to be on the bottom. It's just whatever's in these parentheses right here. We're going to have x plus 4 and times x minus 1. In this case, the bottom does count. We're not going to ignore it because the bottom is not always positive like it was in number 10. So on our sign chart, we're going to have points at -4, -3/2, and 1, positive 1. And we have an odd positive sign chart in this case, so this is what it's going to look like. And we can go ahead and start writing the answer. We know our critical points are going to be at x equals -4, x equals -3/2, and x equals, it should be +1. I think I wrote -1 down, but it should be +1 because that's what's on our sign chart, because x minus 1 equals 0, x is equal to 1 in that case. So this is not -1, this is +1. We're going to have f increasing from -4 to -3/2 because that's where f prime is positive, and then also at 1 to positive infinity because that's where f prime is again positive. And we're going to have f decreasing from -infinity to -4 because f prime is negative there, and -3/2 to 1 because f prime is also negative there. So that's going to be our answer. And just to kind of clarify, if you remember at the beginning of this worksheet, when we were talking about defining the rule for critical points, we said a critical point in f is where f prime is equal to 0 or does not exist. Technically, at points -4 and 1, f prime does not exist, and that's why those are critical points. Because -4 and 1 will cause, the bottom of the fraction to equal 0, that will cause the fraction to not exist. So technically, I should have written because f prime is equal to 0 or does not exist there. This is the only instance of this on this worksheet because it's the only time where we're actually using factors from the denominator of the derivative equation to make our sign chart. So just keep that in mind. Sometimes critical points exist in f because at that point in f prime, they do not exist. And in this case, x equals -4 and x equals +1 are critical points for f because they do not exist in f prime. Okay, or like f prime does not exist there, would technically be how you write it, I guess. Let's move on. Number 12, we're going to have a chain rule and product rule. So chain rule from e to the 2x, and then obviously a product rule because we have two things being multiplied together. And we're going to get 2e to the 2x times x minus 4 plus e to the 2x. This 2 comes out because of the chain rule, in case you were wondering. But we can actually go ahead and cross out e to the 2x. We can take that out and then cross that out completely because e to the 2x is always positive and therefore will not be affecting our sign chart. We're left with 2x minus 8 plus 1. So that leaves us with 2x minus 7, and that's our only factor in this case. So the only place in the sign chart that the line will touch on the axis, I guess, is 7/2. It's going to be odd positive. It's essentially a line going from negative to positive, looking something like this. And our critical point in this case is obviously going to be x equals 7/2. And that is because f prime equals 0 there. f is increasing on 7/2 to infinity because f prime is positive, and f is decreasing on negative infinity to 7/2 because that's where f prime is negative. Super straightforward, as long as you recognize that e to the 2x is always positive and does not affect the sign chart. Number 13 is a little tricky, just because when we draw the sign chart, we can't kind of rely on the methods that we usually use. We just kind of have to recognize what a trig graph kind of looks like and draw it based on that. But we go ahead and do our first step, which is taking the derivative, giving us -10 sine, and then 2x in the parentheses. I'm just going to go ahead and determine the period for this problem. Determining the period is basically 2 pi over b. b is the number in front of the x in the parentheses. So in this case, it's going to be 2 pi over 2, giving us a period of pi. Basically, the period is to help us to draw the whole period on the sine graph, kind of figure out from what to what is a full, actual, SINE chart, or SINE graph to put on our SIGN chart. So we're going to put our full period down, 0 to pi, and that's also our interval as given in the problem. And pi over 2 is going to be our middle point right there. So a SINE graph looks something like this. So that's how we're going to kind of determine where the graph is negative and positive. So now that we have that, we know that our critical point is at pi over 2, because that's where f prime of 0 is that's where f prime is equal to 0. Sorry. If you plugged in pi over 2 into this derivative equation, you'd basically get sine of pi, and since sine of pi is equal to 0, the derivative of y would equal 0 there, which is why it's our critical point. I think I forgot to write that because of f prime equals 0 part in this one, but make sure that you are including all 3 components that we talked about at the beginning: the question, critical point, the answer that we got from our graph, x equals pi over 2, and then our rule, which would be because f prime is equal to 0. We know that f is increasing on pi over 2 to pi, because that's where f prime is positive, and it's decreasing on 0 to pi over 2, because that's where f prime is negative. We don't have infinities in this case like we did in number 12 and all of the other problems, because we are given a set interval. So we know that in this case we're looking at only the graph from 0 to pi. We're not looking at anything else. But yeah, that's the final answer. Trig functions are still pretty straightforward. They're just a little more confusing because the SIGN charts, the sign charts, are a little more difficult to determine because you have to base it off of the actual trigonometry graphs, or in this case, the SINE graph. The next 2 videos that we're going to have are going to be about concave up, or finding where our functions are concave up or down, and finding where functions have a relative min or max. So be on the lookout for those 2 videos. There's kind of a similar process where you do have to look at another graph to determine, you have to look at another function to determine aspects about the original function. If you enjoyed this video at all or found it at all helpful, please give it a like and subscribe to our channel to see more calculus videos. Thanks so much!